Thank you very much, Chris, for that introduction. I just want to say that the Center for Human Metabolomics is also part of DIPLOMICS. We're a proud DIPLOMICS partner lab, Liam. So it's going to be difficult for me to speak after these three guys that just spoke, because I have quite a different presentation prepared today. So I have the task of telling you what metabolomics is. And because I only have 10 minutes to do that, I asked AI to tell me what metabolomics is. And I couldn't understand it. So I then going to try to tell you from a human intelligence perspective what metabolomics is and why we need to share it. So when I asked ChatGPT, what is metabolomics, that was the definition. Metabolomics is a branch of omic science that involves the I'm not even going to read it, because even for you guys doing metabolomics, you wouldn't understand what it says. So we still do need human intelligence, even in 2023. So what is metabolomics really? If you think about your genome and your whole set of genes as the university, and within the university, there's a university professor. In the same way, your genome, there's genes. And the function of this professor is to deliver certain people with certain skills to the society who can provide a certain function. In this case, that professor is producing craftsmen. And the function of the craftsman is to take wooden logs and make beautiful furniture from the wooden logs. In the same way, you have your genome with a specific gene. The gene encodes for a specific protein, which is that one, and the protein also converts one compound to another one. And these compounds are referred to as metabolites. And what is metabolomics? Metabolomics is measuring these metabolites. So just for you out there who finds this very boring, I added methylmalonic acidemia as an example. So you can look at this protein as methylmalonyl-CoA mutase, which converts methylmalonyl-CoA to succinyl-CoA. So what happens if this university professor goes on leave or is not doing his job properly and is not delivering any craftsmen? Well, then, if there's no craftsman, the wooden logs would certainly pile up and accumulate. In the same way, if there's a certain mutation or a specific genetic defect, then the protein doesn't function. In other words, the substrate will pile up or it will accumulate. In this case, if methylmalonyl-CoA mutase isn't working, then you will find accumulation of methylmalonyl-CoA. And in metabolomics, we can use these profiles to diagnose the disease. So if you do a metabolomic study and you measure methylmalonyl-CoA and also succinyl, then you'll see that there's a lot of the substrate, there's no product, so this patient probably has a problem in that enzyme. But it's not that simple, because the wooden logs isn't the first thing in the whole chain of the production profile. Before you get the wooden logs, there's someone cutting the trees, and that guy is still doing his job. So even if the professor isn't doing his job and there's no craftsman, that guy is still cutting trees. And he's still bringing you all these wooden logs constantly. And in the same way, propionyl-CoA is still keeping on converting to methylmalonyl-CoA despite the defect that you see there. And this has a toxic effect, because you can just imagine if those wooden logs pile up and no one is removing them, then the wooden shed where you store them will start breaking. The windows will break, the doors will fall off, and there will be a whole lot of damage. So in your body, this is the same thing happening. If you have a substrate metabolite that's accumulating, it will convert to a toxic metabolite, in this case methylmalonic acid, and that methylmalonic acid is a toxic compound. And that is what leads to many of the disease symptoms that you see in these methylmalonic acidemia patients. And in the same breath, you also do not get the lovely wooden chairs. So the wooden chairs were maybe there to have a certain function of serving in a matric class as chairs for those pupils. And now the pupils do not have chairs, and that also has not a toxic effect, but it has a detrimental effect on the actual function that it was supposed to have. So if there's no product, then that's the other side of the coin. You also see some of these symptoms because the product cannot perform the function that it was supposed to intended to do. But it's also not as simple as that. So in many cases, the professor is still there, but just very slow. So he's teaching these pupils slowly. So he's providing the correct craftsmen, but the craftsmen aren't enough. Or he is providing craftsmen, but the craftsmen do not function properly as they should. So this means that even if you find the wooden chairs, they are being produced at a slower rate. So when you do metabolomics, you will see the wooden logs and you will see the chairs, but the ratio will be different to what you will see in someone who has the craftsman doing his job properly. And in the same way, in your metabolism, you will find some of the product and you will find some of the substrate, but in a different ratio. And then you take reference ranges of normal populations and you map it against that to make your diagnosis. But it's also not just as simple as that, because the wooden craftsman doesn't only make chairs. He can also make tables, he can also make cupboards, and he doesn't only use those logs, he can also use different logs, different colored logs, or anything. So the proteins in your body and the enzymes also has different functions. They can work on different substrates and they can produce different products. And this makes it difficult when you do metabolomics because you don't just see one answer straight up, and you need to do entire metabolic profile in order to identify this defective enzyme. And this is why I have the fingerprints there, because in metabolomics and also in proteomics, this is referred to as the metabolic fingerprint. So this is what we do every day. We do metabolomics on samples and we identify the fingerprint, and the identification and interpretation of these fingerprints is a science all on its own. And we have pathologists and medical scientists who specialize in looking at the patterns in those fingerprints to identify the defective enzyme. But I don't know if you got that, if you look at the craftsman. Okay. So sometimes you do these profiles and you see the fingerprint, and the fingerprint tells you there's no craftsman. And then you do proteomics with Liam and you see, no, there is a craftsman. So what now? What's going on now? But the craftsman, if you can see there carefully, doesn't have his tools anymore. So in a lot of instances, these enzymes do need cofactors. They need tools to do their job properly. And you see the same phenotype, or you see the same metabolic fingerprint when there's no craftsman, and also when he doesn't have tools to do his job properly. In the case of methylmalonic acidemia, you see the same profile with vitamin B12 deficiency. So when you see the profile, you really need to be careful before you make the diagnosis, because is it the enzyme or is it the cofactor leading to what you see? Because the treatment will obviously be a lot different. It's also not as easy as that all the time. So sometimes you see a profile of a patient, so you see his phenotype. You do all the metabolic screens, you do the genetics, you do the protein work. You still cannot explain the phenotype. There's no way. So in this example, let's say you see a matric class that's failing matric. But you cannot even though you look at everything, you cannot find the reason for that matric class failing. Here you see the same thing. So you see a set of symptoms and a patient phenotype, but with the metabolic fingerprinting, you do not see what's going on. You cannot make a diagnosis. And what now? And this is where data sharing comes in. Because you can now imagine if you have a matric class failing, and in 3 years from now you have another matric class failing, and suddenly you have someone from the outside who sees the pattern and says, but every time the matric class fails, it's because they didn't have chairs. And now you can start getting some answers. So in metabolomics and proteomics and genomics for that matter, it's exactly the same. You have this patient with a specific phenotype. You do the profiling, you've got no idea. 2 or 3 years from now, you get another patient with the same phenotype that you also cannot explain. When you are sitting in Kimberley and you did the metabolic profiling, someone else is sitting in Worcester doing this, also did a profile on a patient with the same phenotype. You're still sitting with the same problem. Neither of you will be able to make or see a pattern. But if you could come together and you could share your data, and you can have 2 profiles of patients with the same phenotype, and now you have 2 sets of metabolic profiles, maybe now you can see, oh, it's because they didn't have chairs. And now you can start making these connections as to what's happening with these patients. And this is why I urge everyone to start sharing your data. And we've heard this throughout this conference, in every single speaker saying it, but we really need to do it. We really need to start sharing data. And metabolomics is not just for diagnostics. Even if that's our focus at the Center for Human Metabolomics, it's not the only thing that you can do with this data, because think of a treatment. You know, if you see that it's the logs that's piling up, you can try to find a mechanism to remove the extra logs and the cabin will not break. Or you can try to get wooden chairs from somewhere else so that the process at the end and the matric class can still go on with their classes. So you can remove the toxic effect, or you can introduce the effect that's no longer there. And again, I want to say this. If you're a researcher, share your data. If you're a patient, force your doctor to enroll you in the Nngwe project, even if you're diagnosed, so that we can get the profiles in a database so that we can share that and build up a whole big data, of information. And if you're a medical doctor, remember, if you share your phenotypes with fellow doctors and with the Nngwe program, the chances that you will get an answer is so much better than doing this alone. Thank you very much.